So for the second half of the week, we're just going to kind of review what we've done with functions so far. So this is function notation for equations. If the main thing is that you know when they're giving you an x or a y, whether they're giving you an input or an output, and that you know to check the function names. So when they give you a number inside the parentheses, it's an x. And when they tell you to evaluate it, they're essentially telling you just plug it in. And you have to be careful because I'm plugging this into the g function, okay? So I'm going to take the g function, but instead of x, I'm going to put -2 in parentheses. So in this case, -2 squared is going to give me +4, but this negative will make it negative again. And then all I have to do is add, and I get -2. So g of -2 gives me -11. So the input or the x was -2 and the output or the y would be -11. The next one wants me to do the f function. So I'm going to take the f function, but instead of x, I'm going to put -1. And I just, evaluate it, see what it equals. So 4 times -1 is -4 minus 7 is -1. Oh, that's funny. They both turn out to be -11. So my x or input is -1 and my y or my output is -11. Now, when they give you something like this, they're giving you the y value and they're wanting you to solve for x. So I'm going to take 5 and set it equal to 4x minus 7. And then I have to see what that equals. So to get rid of -7, I add 7 to both sides. So that'll give me 12 equals 4x, and then divide by 4. So x equals, oops, that was a weird place to put my equal sign, equals 3. So what that means is if I had plugged in 3, I would have gotten out 5. For this last one, they did not give me a number in the parentheses. They gave me a y. So I'm going to set this equal to the g function again. So I get -28 equals -x squared minus 3. And I'm going to solve. First by adding 3. So I get -25 equals -x squared. Whenever you have a negative in front of a variable, it's essentially like having a -1. So I'm going to divide by -1 on both sides. And I will get x squared equals 25. And when I take the square root of that, I'm going to get plus or minus 5. Because whether or not I added 5 or subtracted 5, whether I squared positive or -5, I would still get 25. So what that means is that whether or not I plugged in +5 or if I plugged in -5, I would still get -28. Okay. So, just as a review, domain is all of our x's or inputs. And range is all of our y's or our outputs. And whether or not something is a function, we're looking for every x has only one y. And in order to check that on a graph, we do the vertical line test. Okay, so let's have a few examples. So vertical line test, I always start with the vertical line test. No matter where I draw a vertical line, it will only ever touch one point at a time. So I'm going to say that yes, it is a function. For domain, I have an arrow to the left and the right. So I don't have any boundaries to the left or the right. So it's going to be all real numbers. For my range, I do have a It never goes below this point. So I'm going to say my boundary is 0, and since all the points are above that, it is greater than or equal to 0. So remember, with domain or range, we're looking for boundaries, and we're looking for if it's above, below, left, or right, bigger or smaller, that sort of thing. Whenever you have points, vertical line test still applies. So no, this is not a function because all those lines touched more than one point at a time. And with dots, I'm going to make a table because it's just going to be, my domain and range is just going to be a list of my x and y's because there's not really boundary points because I only have specific x's and y's for each point. So I have -3, -2, -3, -3, -2, -1, -2, 0, -1, 1, and -1, 2. So those are all my points. There you go. So for my domain, I am going to just list all of the x's, but I don't have to repeat numbers, and I should go from least to greatest and put them inside braces because I'm talking about a set of specific numbers. So I'm just going to say -3, -2, and -1. That's my domain. All of the points have one of those numbers as their x value. For range, I'm going to do my y's from least to greatest. So the smallest number I have is -3, then -2, -1, 0, 1, or 2. And what that means is that all of my y's have at least one of those has one of those numbers as the y value. Cool. Okay. So for this one, vertical line test doesn't matter where I touch, or where I draw it, only touches one point at a time. So yes, it's a function. For domain, I'm looking from left to right. So the furthest left that it goes is here at -5, and the furthest right that it goes is 6. So remember that when you have boundaries on two sides, you're going to do a compound inequality. And in this case, because I have an open hole here, that part does not get an or equal to, because x is going to get really close to 6, but it's never going to actually touch the number 6. So it is less than or equal to 5 because there's an actual point there, but it is just less than 6 because there's not a point there. For range, I'm looking at the y, which goes up and down, so upper and lower boundaries. So the lowest it goes is from -6, and the highest it goes is 2. Neither of those have holes, so they both get less than's or equal to's. Okay, for this one, vertical line test, there's lots of places I can draw a line where it touches more than one point at a time. So no, it's not a function. For domain, left and right boundaries, well, here is a boundary. Nothing is to the right of that. So my boundary is at 2, and everything's to the left. So on the x-axis, that means all of my x's are less than or equal to 2. Biscuit. Shh. For range, there is no upper or lower boundary because I have arrows in both directions. So when there's no boundary, that's when I say all real numbers. Okay, last thing, function notation with a graph. So the important thing here is just to know, are they giving you x or y? So here they gave me that Biscuit. Come here, Biscuit. Come here. Biscuit. So So they gave me that x is 0. So I have to find, come here. I have to find the y value when x is 0. So x is 0 right here at 4.5. Next, they gave me an x where x is -3, so at -3, once again, y is 4.5. Now, when they say find x, here they didn't give me x, they gave me y. All right, so I go where y is 0, which is technically the x-axis, and every single time that the graph touches, I have to recognize that. So there's more than one answer. So here, the answer is both -4 and 3. For the last one, everywhere where x is 4.5. So in this case, we have 3 answers. We have x equals -3 right there when x is 0 and when x is 5. So if it happens more than once, you have to give it all of the places where it touches at 4.5. Anyway, so that is function notation and domain and range, which is the main ideas with functions. So make sure you come to the live meets, do your homework. If you have questions, please ask. And I will see you guys later.